What if everything we believe we know about the universe is incorrect? The James Webb Telescope just discovered galaxies that are too large, too ancient, and too advanced to exist. It's picking up signals from outside the edge of space. There's a strange pulse, a beat, resonating through the universe. And a beam of light just reflected back from something. This is not science, it's a warning. Reality could be shattering. And we may not be the only ones. Come join us. For more than a century, we believed we had the universe more or less under our control. From the Big Bang to the origins of stars, galaxies, and planets, everything fit into a pattern, a timeline grounded in reason, tested through observation, and validated by mathematics. But what if that timeline is mistaken? Suppose the rules of physics, the same ones we apply to explain everything from apples falling to planets orbiting, just didn't work at a cosmic level. And suppose the world's most powerful telescope has not only looked deeper into space, but looked at something it wasn't designed to look at, something that defies the laws. What did we get wrong about the universe's history? And why are scientists now reconsidering all that they previously accepted? The universe, the standard cosmology says, started about 13.8 billion years ago in a single burst of rapid expansion known as the Big Bang. If this kind of story touches your heart, if you're someone who cares about truth, responsibility, and speaking up for the voiceless, please like this video, subscribe to our channel Spark Science, and share it with someone who should hear it. Let's get started. This was not an explosion in space but an expansion of space itself, a moment of near-infinite density suddenly radiating outward. Not long after, the universe was filled with hot, dense plasma of radiation and particles. With a decrease in temperature, the atoms were formed, and after approximately 380,000 years of the Big Bang, light was able to move freely through space. All that residual radiation is what we presently observe as the cosmic microwave background, a wispy glow that fills the entire universe and behaves like a baby photo of all that exists. From there, the universe expanded, cooled, and matter started aggregating by gravity. Slowly over hundreds of millions of years, the first stars formed, and then later on, small protogalaxies started to form. These initial structures gradually coalesced and expanded into the great galaxies we observe today. In this model, hundreds of millions, even billions of years would be required for galaxies to achieve the size and sophistication that we find in our local universe. This is what our models have been saying to us for decades, that cosmic structure builds up over time. The Hubble Space Telescope, released in 1990, assisted in verifying much of this story. It revealed galaxies in different states of formation, aided us in estimating the pace of the universe's expansion with something referred to as redshift, where light coming from remote objects distorts as room itself distorts, and gave us some of the first accurate measurements of so-called Hubble constant, the rate at which galaxies are moving away from us. Redshift also made it possible for astronomers to calculate how far away, and thus how far in the past, a galaxy or star is. And based on this, we place boundaries on the observable universe, the part of space that has had time to send light to us since the start of time. To account for some still unresolved enigmas, such as why galaxies do not disperse and why the universe is accelerating, scientists proposed two central concepts, dark matter and dark energy. Dark matter has long been believed to constitute most of the mass in the universe despite not emitting or absorbing light. It's the unseen glue that keeps galaxies intact. Dark energy, by contrast, is thought to be the driver of the accelerating expansion of the universe, such as an invisible pressure driving everything outward. Neither has ever been seen directly, but both work in the equations and fix the issues, at least for now. All of these ingredients fall under what's called the lambda-cold dark matter model, the standard description of the universe. It puts together Einstein's general relativity, quantum field theory, and cosmic observations in one consistent picture. And until recently, this model explained nearly everything we observed, from galaxy rotation curves to cosmic matter distribution. But there's a problem. It requires that the assumptions that we made regarding the early universe be right. And that's where things are beginning to come apart. Along comes the James Webb Space Telescope, or JWST. It launched in December 2021 and came online by mid-2022. Webb was not created to succeed Hubble but to gaze even farther back in time, deeper into the cosmic past than is possible with Hubble. Webb does not operate on visible light, as Hubble does, but on the infrared end of the spectrum. Why does that make a difference? Because light from the first galaxies has been so smeared out over billions of years of expansion that it's now only visible in infrared. That is to say, Webb can detect the most faint, most ancient signals from the farthest reaches of the universe, possibly from just a few 100 million years after the Big Bang. Now, Webb discovered mature, giant galaxies where there shouldn't be any. And if they exist, then something is seriously wrong with our understanding of the universe. Just months ago, scientists using the James Webb Space Telescope uncovered something so alarming that it's being described as a crisis for modern cosmology. It's not a distant theory or an abstract idea, it's actual data, fresh from the edge of space and time, showing us galaxies that simply should not exist. These galaxies are not faint smudges or borderline objects, they are massive, brilliant, and fully developed, occupying the space where no galaxy so advanced has any business being. The most astonishing aspect? They existed only 280 to 300 million years after the Big Bang, just about the blink of an eye in cosmic evolution. So the question now is agonizingly simple: how did whole galaxies, with hundreds of millions of stars, appear when there was allegedly no time, no materials, and no physical possibility for them to be there? The James Webb Telescope, with its unparalleled sensitivity to infrared light, spotted a number of these impossible galaxies shortly after it started full operations. In them are today household names such as JADES GSZ 14-0 and MOM Z14. They're not only intriguing discoveries, they're rewriting the history of the early cosmos. JADES GSZ 14-0 is now one of the farthest galaxies ever seen, with a redshift of about 14.18. That puts it only about 280 million years after the Big Bang. In the meantime, MOM Z14, with a redshift of around 14.44, is currently the record holder for the earliest established galaxy in the history of the cosmos. But it's not so much how early they look. It's what they are that is turning scientists inside out. In accordance with the standard cosmological model, galaxies take their time to develop. Gas first accumulates in halos of dark matter, gradually cooling down until they eventually form stars. Those stars coalesce into clusters, and after hundreds of millions of years, a sufficient number of stars congregate to build a feeble, primitive galaxy. These initial galaxies should be small, faint, and disorganized, only visible to even a telescope as able as Webb. But JADES GSZ 14-0 and MOM Z14 are just the opposite. They are too large, each of them harboring hundreds of millions of solar masses worth of stars, perhaps even more. They are too luminous, shining with powerful ultraviolet and infrared radiation, which signals heavy star-making activity. And worst of all, they are too chemically evolved, i.e., they already possess elements such as carbon, oxygen, and nitrogen, which must only have formed after several generations of stars lived and died. It represents a paradox. At that stage in the history of the universe, there shouldn't have been enough time for even one complete star lifetime to run its course, let alone a few. The fact that there are these heavier elements, so-called metals, indicates that stars already existed, exploded supernova, and sowed their environs with enriched material. That alone should have taken hundreds of millions of years. And yet here we are, witnessing galaxies in which this has already occurred, only 200 to 300 million years after the so-called dawn of time. Why is this impossible? Because according to all we believed we knew, the universe was still in its turbulent infancy at that point. It was hot, dense, and dominated by neutral hydrogen. Star formation ought to have been slow and inefficient, with small galaxies building up gradually over vast periods of time. These new galaxies contradict that image completely. They are well-formed, bright, and enriched, and they appear too early, too abundantly, to be compatible with any existing theory of galaxy formation. And they are not isolated oddities. Webb has now found dozens of comparable galaxies at similarly record redshifts. We're not talking about one or two flukes. We're talking about a population, a whole class of ancient, oversized galaxies that appear again and again in different fields of view. If just one of them existed, it might be explainable as a statistical outlier or a misreading of the data. But with this many, across this wide a region of space, that explanation collapses. The issue isn't with the observations anymore. It's with the theory. According to normal galaxy models, an average galaxy produces some 10% of its gas in stars throughout history. This is a relatively uniform pattern that has been well observed in thousands of nearby galaxies. But JWST has discovered early galaxies that appear to have turned nearly 100% of their gas into stars, with no dust, no clouds of gas, just pure starlight. That's like seeing a city construct itself overnight with no scaffolding, no leftovers, and no history of building. It doesn't simply ask questions, it shatters assumptions. Some researchers are now calling for a stark dilemma: either we are wrong in our assumptions about how galaxies come into being, or we are wrong in our assumptions about when they come into being. A researcher summed it up bluntly: either our early galaxy formation models are spectacularly deficient, or our understanding of the cosmic timeline is inherently broken. This is no argument over fiddling with some numbers in an equation.